All right, let's look at this problem called minimum window substring. Essentially, in this problem, what's given to us is that we are given us two strings S and T, and we have to find a substring in S which contains all characters of T. Uh, it doesn't. So let's have a read like the exact statement. Given two strings S and T of lengths M and N respectively, return the minimum window substring of S such that every character in T is included in that window. If there is no such substring, return the empty string. Okay, so let's understand the problem better and switch to a whiteboard. So the example that is given is A T O B E and then CODE, Adobe Code, and BANC. This is the example input and S, and the example T that is given is ABC. So what we have to find is the smallest substring in S which contains all characters of T. There is no ordering like A, B, and C should come in a specific order. It's just that they should be present. So the first thing to understand is, hey, how do I know if a substring or rather simple ask? So let's first divide this problem into how to check if a string S contains all characters of string T, right? How do I even check that? So for to do that, I need the counts of characters. So for example, here from ABC, if I can build that, hey, A occurs one times, B occurs one times, and C occurs one times. And what this other string as, if I build the same map, right, and then let's say this guy's A, B, C, and some other characters. Other characters I'm actually not interested in, but still I build this and I build the count. And what I have to do is this for every char, or for every key in this, for every char in C in ABC, count of C in T, or rather count of C in T should be less than equal to count of same char in S. Basically, S should contain each character at least number of times which it contains in this. That's the basic criteria that can tell us whether or not the string contains all characters of T or not. And post that, now we're looking for a minimum substring. So for example, in this, we first build, let's say, this count map, and then we start building the count map for this string. And we are only interested in A, B, and C. Any other character we just ignore, right? So we take A, B, C, and we check. Okay, A occurs one times, D not interested, O not interested. Okay, B occurs one times, and then occurs. E is not interesting. C is interesting. So we go one, right? So this is at this, so we can also maintain how many characters meet the criteria, right? We can also maintain something called as, let's say, matching chars. And so when I incremented count A of one, I checked, hey, I only needed one, so I'll say match has increased. Then similarly, when I made B as one, and I'll check, hey, B, I only needed one time, so B is also there. And then for C, again one I needed one. So I know, so as when my matching char becomes equal to the size of this map, is when I know that hey, all of my characters are now matching. So this is the first substring which contains all the, or the first window which which contains all the characters matching. Now what about now when this happens, you would want to reduce the window to see if there can be a smaller window ending here that could meet the criteria. So at this point, we'll use a window shifting. So now we first reach here. Now we'll shift the window. So we'll remove this A, and we go to this T. Now we could also, since we are only interested in B, we could also keep like a indicating the pointers where interesting characters are. So the interesting character was first at 0, then the interesting character was 0, 1, 2, right? And maybe we can maintain this information in some queue or something, so that now when I want to shift or decrease my window size from A, I don't move to D because D is of no interest and O is of no interest. From A, I can directly jump to B if I maintain these pointers in my first pass. Okay, so anyways, so now I shift to B and now I check, and when I do that, my count of A decrements. My count of A becomes 0 and I no longer have any matching characters. So now I am currently at this BEC window and I increase further. So from BEC, now I go to O, then I go to D, then I go to E, then I go to B. So B's count increments to 2, and then I go to A and A's count become 1. And when A's count become 1, again I have a match, right? So from this B to this A, I have another match. And when that happens, I'll again try and reduce my window. So from this B, now I look at from this C. So from this C to this A. So when I reduce the first B, this becomes 1 again. And even this is a match, right? C, B, and A all are present. Then I jump further. So, and then I jump further. That means I go to what? This BA. And then when I am, because I removed this C becomes 0. So I need a C. And then when I go further, I find this C. And then I go, hey, yeah, find a C as well. So now again 3. So I have to maintain few things, right? One is, so we are doing uh, so while expanding window on right is easy, right? Just move, right? Just move and maintain a list, maintain queue of interesting characters, right? So this is so that when you jump your left pointer, you know exactly where to jump to instead of one character. And other than that, you maintain like a matching char count. Okay, let's come to the core and see if all of it makes sense or not. So the first thing that we are doing is obviously first analyze the T string and build like a map of count of every character. So let's say we take a map and we say, hey, I am interested in for every character knowing the count. For every character, I want to know the count, and I'll call it like a T count, right? And this is equals to like a new, say, we build a hash map. So what we do is for each character in the T string, we'll do T count dot put character C, and we'll increment the count. So you can use get or default um, C count 0, right? So this is basically increment the basically build a count map for all the characters. Now all the characters in T are the only characters that I am interested in. And then now I'll do the same thing in S, and I'll find how many matching characters I have found. So let's maintain a variable called matching chars and initialize it to 0. Right now I don't have any matching variable. And then what do I do? Um, Initialize. So in the final result, I have to return a string. So let's also maintain like a length int and initialize it to maybe some large value. And okay, so start, let's say 0 and some initializing stuff, right? And at the end, this start and end is what let's say we'll try to maintain. So at the end, we'll return like a f dot substring start and end plus one, right? Now let's take our for our window, let's take L and R. So initialize L to 0, R also to 0, and now let's start moving the R pointer. So while R is less than that's dot length. Now what exactly do we want to do here? One is I want to maintain all the list of interesting characters in a queue. So let's also build in a queue of indexes is fine. So queue of integer, just call it queue equals to new linked list. And now I'm going through the list, and I'll keep going through the list till my matching characters become equal to the size of the count, right? So there are two things. So let's look at the character. So the character is start at R. And now if there are two cases, one is if the character is interesting character. So if it contains if it's present in the T count, right? Then only it's interesting character. Otherwise, though, I don't have to do anything. So I don't do anything means don't do anything at all. And uh, and obviously you are also increasing our now. But if it is an interesting character, first thing I want to do is probably put it into the queue. So queue dot add whatever the index is, which is R. So this is one of the interesting characters. And the reason I'm maintaining this queue is when I'm shifting my left, I don't want to shift my left one by one. Rather, I want to jump my left from current to the next interesting bit, which is where I'm using the queue. And then what else I want to check? Well, I want to also maintain like a T count. I want to also maintain like a S count. Okay. So I also maintain a S count. And what I'm going to do is I'm going to increment the same thing. So what I did for T count for C, now I'm going to do the same in the S count. So S count, and I increment. Now, if at when the value becomes equal to T, so when the count of, so when S count, if, okay, if S count get C, if it becomes exactly equals to T count dot get C, then your matching character has increased, right? Then this is the point when your whatever this matching case we called, that means now I have one match. Now at any point, if the matching characters becomes equal to the size of t count size, then you would want to reduce your window, right? And when I want to reduce a window, I'm going to remove the first character. So you remove the first character, which is what? So I want to remove, but even before that, I want to check like, okay, so my matching it is matching. So this is a, so current substring is a substring that matches. So int, let's check current length, which is equals to r minus l plus 1. And if the length that I have been maintaining, if that length is, if this length, whatever length I'm getting, if it is less than whatever length I've been maintaining, then I have to update that also. So length equals to current length. I update the start and end as well. So start becomes L and end becomes R, right? That's one thing for updating. And now I want to shift my window. When I want to shift my window, I want to remove the character at L. So I want to remove the character at L. And when I remove, what does it exactly mean? It means that in my um, S count, it must be present in S count. There is no doubt about that. So in S count, I put S count dot get C, not C remove. I decrement its count, and if I decrement the count and its total count becomes lesser than t, then there is a problem, right? It could have been that, hey, in t this character occurs 3 times, and in as so far this character has occurred 20 times. So removing it one time is not going to really make any difference. So you want to remove again. So if as count dot get, if this becomes lesser, then there is a problem, right? Then your matching case reduces. Anyhow, and now let's shift L to the next guy. So what do I shift L to? So I'll shift to, hmm, I could do all plus one, but I'm depending on the Q here, right? So Q stop is what L should be, correct? That is a given. Like Q stop, like that's something that we are maintaining. So Q stop is equal to L. So we definitely do like a Q dot poll. And now, could it be possible that your queue is empty if there is no further point? That's like a corner case, but okay, still. So if to be safe, yeah. So if then you do what? L equals to q dot peak. Fair enough. And now, what do you want to do? So now I want to check whether with this L and the same R, that means here I might want to keep this as a loop, right? If my matching cache does not decrease, then I'll keep wanting to shift the window till my matching cache decreases, right? And then I come out of this while loop, and I'll increment, take a different R, and use that R to check if I can get another string. Yeah, this is fair. um okay, I'm wondering if it will work if the T is like a single character. Let's say if T is just A. Okay, if T is just A, then in your queue you will add A in your yeah, A matches, your length will be basically, then your L won't increment, right? And probably you don't want to, but so if your T is A, then your count, okay, this is fine. Char equals to s dot caret this, you will add index 0 to your queue, and then when you will go into this, you will have a match. But you won't increment L here. That's the problem. Because your queue, after you poll the queue, this your queue will not be empty. So can I simply, in the other case, can I do else L plus plus? Right? That's a specific case, but yeah. So that if I don't know, then I'll just increment L. Otherwise, I'll take L to that specific next interesting position. Fair enough. Okay, now run code. Compilation error. Int char, not a statement. Where is it? Line number 5. Okay, for each char, I think I used it someplace else as well, right? Maybe not. But I remember there is one problem in this, like I think you for equality that you have to use equals, or you can do like a get value, uh, int value or something like that. So you do this, and you add this here as well. Okay, let's run again and fix more errors. Cannot find symbol, line number 39. What did we define? Okay, we defined start, and at the end also so start. So this, let's call it start. Okay, it works. Submit, and some null pointer exception. For A, B, B. Only a few test cases really passed. So can I use this whatever test case failed as an, does it tell me where the error occurred? Okay, it does tell me. Null pointer exception int value because the return value of the statement is null. Okay, so here you are removing a character uh, that assures that it is present. Um, cannot invoke int value, and then you are, where are you invoking int value? Because the return value of get is null. Or maybe because when you're doing less than it is. That is fine. Hmm. I've been thinking a little bit what might be happening. Or let's just do a run through, right? So it is, this is the input. What is the test case? How do I use this as a test case or run this for this? Okay, A, B, and B. Yeah. So this is A, B, and I think this was the problem that I had. Like it's for a single char, but let's run. Okay. So for A, B, and B, let's just walk through. S is A, B, and T is B. So when T is B, it's quite basic. In our T count, B will be 1, like the count of B will be 1. And then we move ahead, we take some stuff here. L and R both are 0. And we are first checking A. A is of no interest to us because it is not present in this. So I'll go into this else part right away, or rather just R plus plus. Now R equals to 1. I'm checking char equals to s dot char at 1, which is b. T count contains b, yes. So I add it in the queue. I do s count dot put. I add it into the thing, which is completely fine. I get the value. Matching chars will be 1, 1. So this all will be 1. I'll come here. I'll do current length. So current length L equals to huh, L equals to 0 and R equals to 1. So 1 minus it plus R. So current length is 2, which is less than the max thing. So then I'll update this, all this is fine. Now I do remove and char remove equals to s dot char at L, which is wrong. I get it now. Because, so okay, so for the approach to work, we are assuming L contains a valid character that is interesting to us, right? Hmm. Let's make this thing okay. So I get the problem. I get the problem. We could essentially we could either find we could put L at the first point. Maybe we do that, which is yeah, but okay, maybe I think that's the better way. So I'll do while L is less than s dot length. Um, you get the character. You do this if your t count is um, dot cat of contains key basically. If the t count contains c, then is I want to break and I can update. Yeah, then I just break. Otherwise, I'll keep moving my L and R to that. So basically, I'm aligning my L and R, the initial L and R, to the first interesting character, right? So I'll always ensure that my L is at always at an interesting character, right? Here, the problem that I was getting was I was trying to remove character from L, but that character from L was not an interesting character. So I just have to move one, 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 one till I get. I don't want to move one, 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 one. Right? That's the whole point. But this is fine, and I think you didn't necessarily need this. I guess if you could do something like a no, you would until else. No, so yeah, I think you could also do something like so I believe this will work. Let's first check whether this works. Okay, run code. All right, it passes. Submit. Yeah, and it works. Now we could also avoid that first pass if we wanted to. I mean, not necessary, but if we wanted to avoid this first pass, what we could do is we know that in the beginning we might have this problem where L is not the right point. So here the assumption that L is at the right point, right? So we could just do this, only do this bit if uh, t count dot, or rather just maybe here, like do this bit only if, right? If it's not even an interesting character, which it could be because the beginning case. So only if it is an interesting character, then I remove it. Otherwise, there is no point in removing. In which case, I just want to shift my L, and I shift my L to the first interesting character, which I have already saved in the queue, and so I'll get it to this, and that will automatically jump. Now let's run this and see if this works, and it works as well. Submit, and we get a wrong answer. 239 test cases passed though. So some small cases is the ones are the ones that didn't pass. So this is one example: A, B, C, and B, C. Your output is C, while expected was B, C. Hmm. Let's see here. You're always checking the current length. You're always updating this. You want the smallest one. C cannot, but C is just wrong, right? Because um, yeah, C is just wrong. So that means you considered your matching case didn't uh, set properly. Okay, let's have a run through. So ABC and BC, right? Okay. So BC will maintain this two. So B equals to one, C equals to one is the thing, and ABC is an uninteresting character. But in our approach, we are our LNR are zero. Yes. So in our approach, we take A. We say A is not present, right? This will be false. So we don't do anything about this A. We move to R. B matches, C matches. When we are at R equals to 2, which is where the matching pairs will become equal, and our length will be 3, right? Initial choice will be ABC, and then okay, I got it. Yeah, if you really want to make it work, essentially the q dot pole is the problem. You can't do q dot pole. You can do q dot pole um, only if this didn't happen. Like only in case of this. So let me do this also. Let's put it here. Yeah, that is it. Now I think it should work. Submit. Yeah, right, it works. Now let's also quickly talk about the time and space complexity. So time complexity and space complexity. So essentially, for the time complexity bit, we are doing essentially using a sliding window approach, and the right pointer in the window keeps moving from to basically right pointer keeps looking at each and every character, while the left pointer has a luxury to jump. So it's essential. And first of all, the number of characters in T have to be looked at once. So which is what? So if you look at here, length of S is M and length of T is N. So first you have to look at N, right? And then you have to R moves M plus M star, right? So what M star is? Uh, M star is number of characters in S which are present in T, right? Because for the left pointer, we are able to jump using this Q. All right. And what is the space complexity? So the space complexity is because you are using this Q, it is M star, right? Because this queue can contain all those different characters. Yeah, so M star, or you could call it O of M, right? But that's the general idea. So both are essentially linear. All right, that's it.